Hello, everyone, and welcome. Today, we're diving into the fascinating world of fluid mechanics with some fun and easy experiments you can do right at home. Fluid mechanics is all about how fluids, liquid, gases behave and interact. Let's get started.
First up, let's explore buoyancy. Buoyancy is the force that allows objects to float. It's why some things sink and others don't. For this experiment, you'll need a container of water, anything that you have at home, anything that will sink or float. First, let's drop the plastic into the water. See how it floats? That's buoyancy in action. And the other things go straight to the bottom. So the plastic floats because the buoyant force or the upward force exerted by the water is greater than the weight of the plastic. The rock sinks because its weight is greater than the buoyant force. So buoyancy is why ships can float even though they're made of steel. The shape of the ship displaces a large amount of water, creating a buoyant force strong enough to support its weight.
Now, let's look at Bernoulli's principle. It says that faster moving air has lower pressure. You'll need a strip of paper and a ping pong ball with a hair dryer. But since we don't have that at home, we use tissue, instead an electric fan for the air. Hold the tissue strip and put it over the top of the fan. The paper lifts because the fast moving air the fan blowing creates lower pressure above the paper, while the higher pressure below pushes it up. Point the hairdryer upwards and place the ping pong ball in the stream of air. The ball stays in place because the fast moving air from the hairdryer creates a low pressure zone that keeps the ball from falling. We are unable to perform this because we don't have that materials at home. The faster the air moves, the lower pressure. This pressure difference is what causes the tissue to left and the ping pong ball to stay in the airstream. Bernoulli's principle is how airplanes fly. The shape of the wing forces air to move faster over the top, creating the lower pressure and lift.
Next, will demonstrate Pascal's principle. This principle states that pressure applied to a fluid in a closed container is transmitted equally to every point of the fluid and the walls of the container. Materials for this: you'll need 2 syringes of different sizes, a tube to connect them, and some water, but we use pink water for it to be properly seen. The procedure is connect the syringe with the tube and fill them with water. Now, if you push on the smaller syringe, you'll see the larger syringe move. This shows how pressure is transmitted through the fluid. The explanation of this experiment: Pascal's principle explains how a small force applied to a small area can create a larger force on a larger area, which is the basis for hydraulic systems. Real-life application: hydraulic systems are used in car brakes and construction equipment. They allow us to lift heavy objects with relatively little effort.
Experiment 4: Viscosity. Liquid drop race. Introduction to viscosity. Finally, let's explore viscosity. Viscosity is a fluid's resistance to flow. Some liquids flow easily, while others are thick and slow. Demonstration materials. You'll need a smooth, slightly tilted surface like a cutting board, but we use the back of the container and several liquids with different viscosities, such as water, oil, and ketchup, instead of honey because we don't have it at home. Procedure: place a drop of each liquid at the top of the surface and let them race down. Observe which liquid flows the fastest. Explanation: water flows the fastest because it has low viscosity. Ketchup is the slowest because it has high viscosity. Oil falls somewhere in between. Real-life application: viscosity is important in many applications, from choosing the right motor oil for your car to designing pipelines for transporting liquids.
So, that's it for our fluid mechanics experiments. We've seen how buoyancy, Pascal's principles, Bernoulli's principle, and viscosity affect the way fluids behave. I hope you enjoyed these simple experiments and learned something new about fluid mechanics. Try this out at home and see for yourself how these principles work. Don't forget to like this video and subscribe for more fun science experiments. And let us know in the comment which experiment was your favorite. Thanks for watching and we'll see you next time.